how many questions we are discussing? Can you remember?
Till most. Sir, 1 minute.
Check out that till which question we did. Structured question 4 or 3 we did.
4.
Huh?
4.
Till structured question 4 we did, right?
Yes, sir.
So it is 4, right?
Yes, sir.
Till here we did. So you wrote everything, right, in your copy?
Yes, sir. Yes, sir. I just print out the worksheet. I will copy it in the worksheet and send it to
Okay.
you.
Okay. Please send me. And you are supposed to send me also the notes.
Sir, I will send both of them together.
When I will get them? Today or tomorrow? Huh?
Sir, within tomorrow they are tomorrow.
Okay, within tomorrow you please send both, huh? Then we can have good discussion on Saturday, okay? So how is everything going? Your family, everyone is okay? How was your Idul Azha? Yeah. Farabi. Hello, Farabi. Again disconnected.
Sir.
Yes.
So
So,
connection gone lost.
so you are submitting by Friday, right? All the
Yes, sir.
things. Inshallah. Then how was your
Sunday I
vacation?
will start the
How
class.
is everything in your house? All are okay? Your mom, your dad, everyone is fine? Hello?
Hello.
Yeah, how is everyone in your house?
Hello.
Yes, I'm getting you. Are you not listening to me?
Hello, sir.
Yes. I'm getting you.
Sir, are you? Hello.
Yes, I'm getting you. I'm hearing you.
Hello,
Check
sir.
your yes. Now you are getting me.
Okay. Yes, sir.
Okay. Thank you. So how is everyone in your house?
Sir, I got all the symptoms of COVID together.
Okay, so your parents,
Fine.
your sister, everyone is fine, right? How was
Sir.
Idul Adha?
Sir. Good.
Good. So you see here we are having the question, question 5, right? We are done till 4, is
Yes, sir.
it? So question 5, can you read please?
Aeroplanes fly at high altitudes where the temperature ice that forms on an aeroplane can flow to the earth and strike the ground. Shows a block of ice falling from an aeroplane and its approaches of airfall. The mass of the falling block of ice is 1.2 kg and gravitational field strength G is 10 Newton per kg. Calculate the weight of the block area. Weight equals to mg, mass into gravity 1.2 into 10.
So what is the answer?
Sir, may I calculate it?
1.2 into 10, you have to calculate it.
No, sir.
So without calculator, you can't do 1 into 2, it is equal to
Okay,
2.
yeah,
That
12.
one, huh?
12. Sir,
12,
I have a
yes.
habit of using calculator now by using it.
Okay, so you now read this part. Read this part. Continue reading. B, part B. So A, your answer is 12
Yes,
Newton. Okay. You
sir.
should you should write the formula also. You should write the formula also and put the values. Then you write the answer. Don't only write 12. Okay. You
Yes,
should show the working also. Yeah. Now continue.
sir. Figure 5.2 is the speed time graph for the block of ice as it falls to the ground. At first, the acceleration of the block of ice is equal to the acceleration of free fall. The acceleration of the block then decreases to zero as the block reaches the terminal velocity. As the block of ice falls, the force F of air resistance acting on the block of changes. State the values of F at time 0.
At time 0, right?
Yes, sir.
So what is the value of acceleration at the time 0? How can you find it? So F is your air resistance, right?
Yes, sir.
So at the beginning, you have any air resistance working?
No, sir.
So it is 0, right?
Yes, sir.
So you should write 0 Newton. Are you writing?
Yes, sir. 0 Newton.
Yeah, look here, we are getting a straight line. That means we have here acceleration is constant, right? For the time being, like till here, we are getting acceleration is constant, right? Till 1
Yes,
second.
sir.
That means till 1 second we have the acceleration due to gravity 10 meter per second square, right?
Sir.
Isn't it? So when
Yes,
we are
sir.
getting this acceleration, that means still we are not getting air resistance. If there is air resistance working, then this acceleration will decrease, right? Gradually. Look,
Yes,
after
sir.
this, we are getting air resistance working and we are having this curve line. Okay. That means acceleration is decreasing. Is it clear?
Yes, sir.
Okay, now we are having next question. What is the next question? Can you read?
State the value of F at time 10 seconds.
So here it is 10 second, right? 10 second, it is constant speed. So at constant speed, we are saying that it is terminal velocity, right?
Yes, sir.
And terminal velocity happens when the air resistance and the weight are equal.
Yes, sir.
Uh, your air resistance is equal to weight. So what was the weight?
Right.
Can you remember?
Sir, 12.
12.
12
So
Newton per kg.
here you will write 12 Newton. Is it clear?
Yes, sir.
And you should also write the reason because you will forget. You write here because air resistance and weight are equal at terminal velocity. Write this note here. Please write.
Yes, sir.
Otherwise, you will forget.
Terminal velocity equal, sir.
At terminal velocity, air resistance and weight are equal.
Oh, weighted equal at terminal velocity.
Yeah, because weight is working downwards and air resistance is working upwards. So resultant force is zero, right? That's why weight and air resistance are equal. You also write result by after writing that you write also comma resultant force is zero.
Number 3, explain why F changes, sir. Because of the no diary or the for
What?
that one. Explain why F changes.
Yeah, why? Why this one changes? Why F changes? F is what? Air resistance, right?
Yes, sir.
Air resistance is increasing, right?
Yes, sir.
Why air resistance is increasing? Because the speed is increasing, right?
Yes, sir. Because
We
speed is
have
increasing.
we have acceleration at the beginning, so acceleration means speed increases. So if speed increases, then air resistance increases. You write that one. If at the
If
beginning,
speed increases,
you write here at the beginning we have acceleration. Acceleration means speed increases. So as speed increases, air resistance also increases. What you wrote?
at the beginning we have acceleration. If acceleration increases, then speed increases.
No, no. You will write at the beginning there is acceleration. As there is acceleration, speed increases. Did you write?
Yes, sir, I'm writing.
Right. At the beginning, there is acceleration.
At the beginning there is acceleration. Acceleration increases, speed increases. Sir, there is acceleration. After that, what I will write?
There is acceleration. So speed increases.
So speed increases.
You know that if there is acceleration, speed will increase, right?
Yes. So
Then next
speed
line
increases.
you write as speed increases, air resistance also
Air resistance
increases.
also. Air resistance also increases.
Is it clear?
Yes, sir.
Now we have this one. Can you read?
State the energy change that take place when the block is falling at terminal velocity.
So the energy changes, right?
Yes, sir.
So the energy was kinetic energy, right?
Yes, sir.
And the friction is working over there. So we are having here uh, at the beginning. Uh, at the beginning, we have gravitational potential energy, right?
Yes, sir.
So gravitational potential energy converted to kinetic energy, and
Kinetic energy.
then kinetic energy converted to thermal energy, right?
Thermal energy. Yes,
Due
sir.
to friction. So you should write this way that at the beginning we have gravitational potential energy, then gravitational potential energy converted to kinetic energy, and finally kinetic energy convert to heat energy. This one you write.
At the beginning, we have gravitational potential energy. Gravitational potential energy converted to kinetic energy. Then kinetic energy converted to thermal energy. The thermal energy na etla?
Yes, yes. At last, it is thermal energy. So during the terminal velocity, actually the kinetic energy is converting to thermal energy, right? As they are asking you when the block is falling at terminal velocity. Okay, that time our kinetic energy is converting to thermal energy. Is it clear?
Yes, sir.
Okay, now part three. Read it.
Correct. Using the information figure 5.2 to determine the maximum kinetic energy of the block when it is falling to the ground with terminal velocity.
So you are given uh, speed, right? Figure 5.2.
Yes,
You have the speed given 40 meter per second, right? And you
yes,
have
sir.
the mass of the object 1.2. So what is the
Yes, sir.
formula of kinetic energy? Can you remember?
Half mv square.
So write it here, half mv square, and calculate what is the value of kinetic energy is coming. Tell me.
So what is the V? Value of V?
Kinetic energy, half mv square.
Yes, sir. Value of V.
You see from the graph, just now I showed you,
Yes,
right? From the graph you can see it, figure 5.2. At terminal velocity, the value of speed is 40, right? 40 meter per second.
yes, sir.
It is V. So got it right?
Yes, sir.
Now you can do it.
K is equals sir 800.
How much it is?
800.
How? How it is 800? It is half mv square, right?
Yes, sir.
So how come it is 800? Your 40 square is 800. 40
Oh,
square is 1600, right?
yes, sir.
Then if you make it half, then it is becoming 800. Then you have to multiply with 1.2
Oh, sorry.
mass,
300.
half mv square. You write the formula, put the
Yes,
values,
sir.
then you calculate.
Sir 960.
960. And what is the unit?
Eh,
What is the unit of energy?
oh, kilojoule. Oh, energy joule, sir.
Yes, joules. So you should also write the unit. Huh?
Yes, sir.
When you are writing the value, you should write the unit also. So it is 960 joules, right?
Yes, sir.
And you should show the working as well. Now continue.
Hmm. The
See
block
part C.
strikes the ground and it stops moving. The impact causes some of the ice to melt. The specific latent heat of fusion ice is 330 joule per gram. Calculate the maximum possible mass of ice that melts as a result of the impact.
So you have to measure the mass.
Yes, sir.
You have to measure the mass. What you are given?
The latent heat of fusion.
Specific latent heat of fusion.
Specific latent heat of fusion.
So what is the formula? Check your notes.
Yes, sir.
Specific latent heat.
Sir, specific latent heat is equal to
Yeah, write this formula here. The formula you write here.
energy by mass by m.
Right here, right here. On the screen you write.
Sir, 'Q by m.
So you are going to find, you are
M.
writing here I or L.
M. I equals to
No, no, not I because
O L. L.
it's LF. Okay,
Yes,
latent heat
sir.
of fusion. Specific latent heat of fusion. This way you should write.
Yes, sir. LF.
LF equals Q by M. So you are going to find M. Then how will write the equation?
Equation, sir. Uh,
M equals
yeah.
Q by
M equal Q by L.
LF.
LF.
So your LF is directly given in the question here. And what is your Q? We told that kinetic energy
Heat Q.
converted to heat energy, right?
Yes, sir.
So this one is your heat energy, 960 joules, right?
960.
960 joule is
960
your
by
heat.
330.
Yeah. So you go for calculation. 960 by 330. 330.
2.1.
2 point
Sir, 2.9.
2.9. And what is the unit? It's M, right?
Yes, sir.
M is mass. What is the unit of mass?
9 kg.
Kg. So you should write it 2.9 kg.
Kg.
Write everything. In your copy, you write everything. Take your time and write everything. Finish everything, then you tell me, yes,
Sir,
you
I
are
have
done.
written it.
You are right.
Everything.
You have written.
Yes, sir.
So done.
Yes, sir.
2.9, is it kg or gram?
Sir, review.
Did you check it?
Yes, sir.
You see here is given in gram, joule per gram. 330 joule per gram.
Oh, gram. It is gram.
So it is coming 2.9 gram. The ice block is 2.9 gram. If it is 2.9 kg, then everything will be destroyed, right?
Yes, sir.
If it falls in your head, what will happen? 2.9 kg, you will die, right?
Yes,
But if it is only 2.9 gram, then it's okay, no problem. You know, sometimes there is ice rain,
yes, sir.
shilabistri.
Yes, sir.
So if it is 2.9 kg, what will happen to your head? You should be careful during writing, and you should check the unit. This is here joule per kg, and Q is in joules, right? So joule will cut, then gram will be left. Is it clear?
Yes, sir.
Okay, now continue. We can rub all this, right? We can clean the screen
Yes, sir.
for the next question. Yeah, continue this. C2.
In practice, the mass of ice that melts on impact is less than the value of calculation in CI. Suggest two reasons for this.
Yeah, in practice, the mass of ice melts on impact is less than the value calculated in C1. Suggest two reasons for this. So, mass of ice we are getting less, right? The one we got
Yes, sir.
2.9. Actually, we are getting less. So why it is? Because the heat we calculated,
Yes, sir.
or
The heat we can.
yeah, the kinetic energy we calculated, uh, that one is giving us heat, right? And the
Yes, sir.
heat we are calculating is not the all heat. Some of the heat is lost in the surrounding area, right?
Yes, sir.
And if we are taking that heat, that time we will get that the mass will not become 2.9, it will become less. Our formula was like this: Q equals, I'm showing you why it is. Q equals M by LF. This was our formula, right?
Yes, sir.
So they are saying our, no, not this one. We are having this formula. M equals Q by LF, right?
Yes, sir.
Just now we did Q by LF. So we have this one, right?
Yes,
Mass
sir.
equals Q by LF. So when LF is constant, LF will be same always, but our some heat is lost, isn't it?
Yes, sir.
So if some heat is lost, that means we are getting here less heat energy, and our mass is becoming less, right?
Yes, sir.
So if that heat is counted, then our mass will be more, isn't it?
Yes, sir.
That's why in practice we are getting less mass of the ice. Okay, so what you'll write, as in practice, some of the heat energy is lost in the surrounding area, so the mass will also become less. You see, the mass of the ice that melts on impact is less than the value calculated. You just write this uh, point in the second line. So you will write so or therefore. At the first point you will write some heat is lost in the surrounding area. Then second line you will write so the mass of the ice melts on impact is less than the value calculated in C1.
So what will we write in the second point?
This one. This line. So you write so. I underline some part, right? From the question, I underline some part, right?
Yes, sir.
That part you will write here. You will write only so or therefore. Okay? Before this part, you will write here therefore, then you write this part. Is it clear?
Yes.
Okay, then complete writing, then you tell me what you wrote.
Sir, the number one, some heat is lost within the surrounding area, and the number two, show the mass of the ice that melts on in impact. Impact less the value calculated.
Is it clear to you?
Impact is, yes,
Did
sir.
you understand or you have any
Sir.
queries on this?
No.
Have you understood?
Yes, sir.
Okay, very good. Then we are going to our next part. C, part C is over. Now D.
As the solid ice melts, it changes into liquid water. Describe in terms of molecule how ice differs from the liquid water.
So this one you have the molecular difference in between solid and liquid, right?
And liquid. Yes, sir.
You got in your book. Also we discussed this one. So you should write them here in 3 points. In terms of molecules, you will write them. In ice, molecules are tightly packed, right?
Yes, sir. So it is on the book.
It is also in the book. It is also in your notes available. I gave you one, table, right? Difference between solid, liquids, and gases.
Yes,
Can
sir.
you check this one? Is it there?
No, sir. Sir,
It's
can
not
you tell
there.
me the
Then,
page number?
then you have the book, right?
Yes, sir.
With
Can you
you,
please
can
tell me the
you?
page number?
Yeah, I'm telling you the page. I'm opening the page. Wait, just 1 minute. You go to unit 9, page 131. Are you
A
there?
solid fixed shape and volume, normally hard and rigid.
Okay, so here we got differences, right?
Yes, sir.
Page number 132. Go to page number 132 now. There is one table.
Yes, sir.
Can you check the diagram? Model of
Yes, sir.
solid, model of liquid, and beside it it's written. You see, arrangement of particles. So in solid, it is closely packed together and occupy minimum space. So
Yes,
it is
sir.
your first point. And liquid occur in clusters with the molecules slightly further apart compared to that of a solid. So it will be your first line. You will write solid is closely packed together and occupy minimum space. Liquid occur in clusters with the molecules slightly further apart compared to that of a solid. This is your first point. Did you write the first point?
And I'm writing.
Yeah, after writing, you tell me what you wrote. So done.
Sir.
What you wrote?
Sir, I'm writing. Solid is closely packed together and occupy minimum space where liquid occur in cluster with the molecules
Slightly.
slightly further apart compared to that of a solid.
Okay, second point you write. Second point you write from the third column you have here for solid. Uh, Solid vibrate about fixed positions. In solid
Solid
molecules, no, in solid molecules vibrate about fixed positions. This way, right?
solid molecules vibrate about fixed position,
Uh, and liquid molecules are free to move about between clusters.
and in liquid molecules are free to move about between clusters.
Free to move about between clusters, but combining within the vessel.
About liquiding in clusters.
Hmm.
Clusters and compare them with
Confined within the vessel, but confined within the vessel. You see, it's written there. Liquid molecules free to move about between clusters, but confined within the vessel.
within the vessel.
Vessels. So this one is your second point, right? What you wrote in second point?
In solid molecules vibrate about the fixed and in liquid they are free to move about between clusters, confined with the vessel. Move
Okay,
between
very good. Okay. That's it for second point. Then third point you write. Third point you write. Uh, Solid molecules have strong intermolecular bonds between them.
solid molecules have strong
You see, that's written here. Strong intermolecular bonds between them. In the third,
bonds.
yeah, in the third column is written. Solid molecules have the strong intermolecular bonds between them.
And the liquid molecules have less.
Yeah, and liquid molecules have less attractive forces between them. And you should also add here in third point, you should also add here that that's why solid molecules, they have fixed volume and shape, but liquids have only fixed volume but no fixed shape.
But not
So what you wrote at last, that's why
That's
Solid,
why solid,
solid,
solid molecule, solid have a
solids
fixed
have
shape,
fixed shape,
shape and
fixed
volume.
volume and shape.
Shape, yes, fixed shape and volume, and liquid have only fixed volume,
Fixed
not
volume,
shape.
but no shape, no fixed shape. Is it clear?
Yes, sir.
Okay, you got 3 points here. Now it's clear, right?
Yes, sir.
This thing here in your this space, you should check that it's related to ice and liquid, right? Water. So whatever
Yes,
you are writing about solid, that is for ice, and whatever you are writing for water, that is for liquid.
yes,
Is
yes,
it clear?
yes,
So done, right? Question 5 is done. You you have any questions
yes, sir.
on 5?
Yes, sir.
You are clear about that. So should we continue 6?
Yes,
Okay. Or it will be your homework.
sir, it's the homework, then it will be better. It will be if it is homework.
Okay, so you try it at home, and on Saturday we'll discuss. Okay?
Okay, sir.
Thank you so much for joining class, and also
Allah
join in
Hafiz, sir.
school's class. Okay?
Okay, sir.
Allah Hafiz. Assalamu alaikum.